Okay, Dan, before we get to the last section on the study sheet, we have to go over some basics, all right? Exponent rules are here, and you have here x to the fourth times x to the third. Now, you can't do anything with different bases, so we're going to assume they're all the same. So x to the fourth is the red, x to the third is the blue. X to the fourth power means x times x times x times x. So x to the fourth in red, 4x's. X to the third means x times x times x, x to the third in blue, 3x's, right? And then if we take all this together, 2, 3, 4, 5, 6, 7, we have our solution, which is x to the seventh. But looking back at our original problem, we can now recognize that x to the fourth, x to the third, wait a minute, all I'm really doing is adding my exponent, okay? Now, once I know this rule, once I know this is the rule, I absolutely know this is the rule, it doesn't matter what I'm dealing with. My rule here is I add my exponents every single time. Add your exponents. So do not overthink this. This is your rule every single time. 1/2 times x to the 2/3. I have to add my exponents. I have to get a common denominator, or I know how to add a fraction to my calculator, which is preferable. So this is 3/6 and 4/6. This comes out to 7 x to the 7/6 or something, right? So, but all of these, it doesn't matter if it's 0, it doesn't matter if it's negative, it doesn't matter if it's a fraction, you add your exponents, okay? Now, if you remember that one, if you can keep that one in your head and say, okay, wait a minute, then what do we do next? If I gave you something like x to the 6th divided by x to the 3rd. Now, you'll be tempted to divide 6 by 3, but really we want to think of it the same way we did this. And we want to think of it two ways. X times x times x, 4, 5, 6, right? X times x times x. Now we look at this and we say, wait a minute, this isn't the same as division. I'm actually going to cancel out all my like terms, and I'm going to be left with x to the 3rd, right? This is x to the 3rd. So looking back at my last question, I say to myself, wait a minute, what's happened? And what happened is I subtracted 6 minus 3 is x to the 3rd. That's all well and good, that's my rule. But wait a minute, going back to this, when I multiply, I add my exponents. When I divide, I subtract. So my thought process starts with this. In other words, if I remember this is when I multiply, I add, then division has to be subtraction. And by that logic, and this will be the last one I do, x to the 4th power raised to the 3rd power, well, I know when I multiply, I add, so when I raise to a power, I have to multiply. It's my only operation left, okay? And that is my rules of exponents. All right, that's it, okay? So what you'll be dealing with, though, in this case, is a little more advanced, or feels a little more advanced, but it's not that bad. 81x to the 8th power, all raised to the negative 3/4. Well, I don't know what negative 3/4 is, but I do have a calculator, so I can do 81 to the negative 3/4 in my calculator. All right. see, fourth root of 81 is 3, to the negative third power is negative, is 27, so this is 1 over 27. Boy, I don't know how to do that in my head, but I do know my calculator is going to give me some decimal. So my answer, my calculator is going to give me some decimal, whatever it happens to be, I don't even know. And then I go math, frac, and it will give me 1 over 27. So again, try this in your calculator. 8 to the negative 3/4, 81 raised to the negative 3/4 power, and it's going to give me some ugly decimal. I don't know what it is. Right from here, without pushing any other buttons, I push math, frac, and enter, and I'm going to get 1 over 27. So when I have it in this situation, I treat this and this separately, just like I have done a couple different times. And then from here, all I do is apply my rule. When I multiply, I add. Therefore, my only option left here is I need to multiply these two together. Once again, not the easiest thing in the world, but I have a calculator. So this comes out to 8 to the negative 6. I'm sorry, not 8 to the negative 6, x to the negative 6. Okay, I'm going to give you another one because that was a little bit screwed up. Ready? Let's do this one. Let's do 64 x to the second to the negative 1/2. Right? So the negative exponent means whatever, but I have a calculator. So I plug this in my calculator and I find out that my answer is some decimal. But I go math, frac, and it comes out to 1 over 8. So that's it. That's the first part. The next part is I know my rule. I multiply this out. I get x to the 2 times negative 1/2. Once again, I love it. That's my thing. So this is 1/8 x to the negative 1. She's going to want you to write it like this, where the x becomes positive, moves to the denominator, but this is going to get you a lot of credit.